Good morning, Sam.
Hi, Sam. Okay, so the only thing that I didn't tell you last week that you really want to know about for the test is how camera works, which we all have lots of experience with this year, and how the eye works and how they differ.
The eye of the camera?
Nope.
The eye of
our
yourself.
eyes.
Okay, so if you are using a camera and you want to zoom in or zoom out or focus, what happens to the lenses in the camera?
It
Take a guess.
expands? Or
What's
Here,
happening
we're
right now,
zooming.
Sam?
We're zooming.
It's going out
The distance
and
between
in.
them?
You change the distance between them. You physically move the lens back and forth of the camera, right? And in the eye, does your lens move back and forth like that, like a camera?
Is it like bends?
No. It does. And how does it bend?
Well, it bends, really. So if I look at, like, the board and then I look at the table.
There are muscles in your eye that are attached to the top and bottom of the lens, and it changes the actual lens. When you focus at a distance or when you focus closer up, your muscles stretch and compress the lens, changing its
That's crazy.
ability to refract. So
Ain't that neat?
it's very neat.
That was crazy.
So for a camera or a telescope or something, you just adjust the placement of the lens, whereas with the eye, you actually change the lens shape itself. And a muscle does that. It stretches or compresses the lens. Okay, so the only other, that's basically review question 9 and review question 10. The only other review questions that we haven't talked about would be the index of refraction of substance A, this is number 7, is 75% of that of substance B. So that's N. So when you're talking about index of refraction, you have N1 sine of the angle equals N2 sine of the angle, where N is the index of refraction for that medium. So if substance A has a lower N than substance B, then in which of the substances will light travel with the greatest speed?
A.
A. So smaller index of refraction means a faster speed of light in that thing. And which substance is most likely the denser of those two? B. Because light will travel faster through a less dense substance, but compressibility, of course, is more important. So, here, this is a setup of one of those labs that are sort of weird in this module, or this is lab 12.3. So this lab has honestly never worked for me, not ever. So I have a new little apparatus, and let's hope for the best. So what we need to do, we'll talk about a little bit. Okay, so we have, again, Snell's law here, the equation I just wrote on the board behind us. And so our first medium, of course, is air, and I'm going to run this laser beam, hopefully, through the air, and it's going to encounter this water, right? And then the light will bend when it encounters the water, and we should be able to measure the angle at which it bends.
Is the laser on?
No, it is not.
Oh, okay. That's why I can find it.
We're going to turn out the light and try to do this.
Or is it gonna like shine on the wall or somewhere?
It's
No,
gonna shine
it
in your
should.
eye.
I'm going to point it along this line right here, but it should shine like somewhere else, and then we're going to measure that angle.
It'll shine right up
Um,
into your eye.
And then we're going to plug it into this equation.
Is that little tub that you have water in it meant for this lab?
It actually is. And
That
it
is
was really
so
cheap.
cool.
And it's certainly not going to work, because it never works for me.
Oh, it
But
doesn't.
hopefully Sam can see it. But will somebody turn on the lights and then come help me with this? Who wants to help me measure an angle?
I'll do it. Well,
That's
I
fine.
can't. See.
Check that out,
Hold still a
Sam.
minute. Okay, we have enough light for Josh to return to a safe position.
Oh gosh, I can't see it.
Okay.
Oh, there it is. Look, Sam, look. Here it is. Josh, what are you doing?
Sorry.
Okay.
Ouch.
So I need to make sure I'm aiming the laser in the right direction. And then, thank you, we need to try to catch the exit point of the...
It worked
Left.
for a second. Did you see it? Like how it was.
So, can you see the pencil? I can't actually see the pencil.
The pencil mark.
No,
Oh.
it's an actual pencil.
Oh,
There's
hold on.
one maybe
I got
over
a
here by my
question.
arm. Okay. Pencil.
On the
Hold on.
floor.
It's not in my lap, my apple's in my lap, okay. Right.
Someone give me a pencil.
Yeah, somebody get a pencil, please. Don't throw it.
Yeah, I won't be able to see.
I don't have my goggles on today. Okay, so we're gonna try not to bump the table. All right, so you see where the laser exits right here?
Mhm.
Make a mark with the pencil right where it's exiting.
Okay.
Okay, do I like your mark? I do like your mark. Okay, so now you can turn the light on.
Ow!
Yeah, all my stuff is over there, by the way. We're gonna have the lens people, when it's your turn to do the lens part of the lab,
Wow.
you're going to have to have
The camera like got used to the dark, so when you flick the light on, it like whited out the whole screen.
Sam.
Sorry, Sam.
Okay, so now what we're gonna do is we're gonna measure this angle. I have a protractor here, and a pencil, of course. Why would I have a pencil? And possibly my pencils in this book. And a bunch of mirrors. Oh, make sure I show you this mirror thing that my friend told me about yesterday.
Ooh.
Here's my pencil.
If we shine the laser thermometer on a mirror and reflect it onto the wall, would it measure the temperature of the wall or the mirror?
The mirror.
Oh, shoot. That
I'm
would have
pretty
been cool.
sure. Okay, so this lab says that we're going to measure this angle. Use a protractor to measure the angle of the incident beam relative to the line in step 2. Well, that's 45 degrees. So, do y'all know what the N for air is? Okay. And then we had the incident angle going in at 45 degrees. So we're going to try to solve for the N of water plus the plastic that it went through, I guess, times the sine of this angle here, which it says we have to measure this. So if that's 45 and my protractor has a big crack in it right there, then
How many significant digits?
I'll try to get 3. Looks like 58 to me. So 58 degrees here. So let's see what we think N of water is. And then we'll see if this tells us anything about the N of water. Did any of the problems have the N of water?
I think you're supposed to solve for that.
Well, yeah, but I mean the real N of water. Oh, here, it says 1.3, so let's see what we get. So we have...
Would all the contaminants in water change that? Like if you have sulfuric water, would it change the N?
Yes. This is terrible. Oh, maybe I did the angle wrong.
I got an error when I did it.
Well, the sine of 45...
I got 0.83.
Yeah, that's what I got too, and that can't be right because it has to be greater than air.
It has to be greater than light. Because it can't be greater than the speed of light.
Well, it's air. I mean, it has to be greater than 1 because 1 is the N of air. And
So
the
what
N
are
of water
what are
has
we
to be
supposed to
greater.
I didn't get with the angles when they were doing that. I had kind of trouble. Are we
Yeah.
supposed to add them together or subtract one from the other?
Well, that's the question. I think we must have measured the angle wrong. So it says, use a protractor to measure the angle of the incident light beam relative to the line in step 2. Well, I mean, if I measure it the same way I measure the 45 degree, then I get 58. But I don't see... I mean, the other option would be, it would be like 138, or no, 122. Let's try it. If this really
That gives
works.
you 0.85.
45 sine divided by 122 sine. I still get the same answer, because of course that's equal. I don't know, guys. I do not know how it wants us to actually measure that. everyone look at page 404 and see what you can think, and turn off the camera so we don't have to fumble around in front of Sam.